Hello everyone, this is the first lecture on matrix algebra. In this lecture, we will discuss about the introduction of matrix and we'll also discuss about different kind of matrices. So,
A matrix is a rectangular arrangement of numbers. The numbers are arranged in rows and columns. For example,
if we take some numbers like 1, 2, 5, 4, 9 and 8.
if we put these numbers within a bracket, then we call it a matrix A, where this horizontal number
Called rows and the vertical numbers are called columns. Here we have two number of horizontal lines, that is number of row is 2, and three numbers of vertical lines, that is number of column is 3. So we can say the order of this matrix is 2 by 3, where 2 is the row and 3 is number of column. In the similar manner, this is a matrix of order m by n, that is it has m number of rows and n number of columns. Here small a indicates the position of its elements. So the first number indicates the row number and the second number indicates the column number to which the element is belong.
Let us discuss about the different type of matrices. First one is row matrix. A matrix having one row and any number of columns is called a row matrix.
This is an example of row matrix, which is a single row and three different columns. Let's come to the second type.
It is column matrix. Similar to the row matrix, a column matrix has only one number of column and any number of rows.
Example, this matrix A has three numbers vertically. So it has three numbers of rows and one number of columns. So it can be written as of order 3 by 1.
Null matrix. Null means 0. So a matrix whose all elements are 0 is called a null matrix.
Here is an example of row matrix of order 1 by 3, which is also a null matrix. Its all elements are 0.
A null matrix can also be a column matrix as shown here. Square matrix. As the name square suggested, it has number of rows equal to the number of columns.
This is an example of square matrix. It has two numbers of rows and two numbers of vertical columns. So its order is 2 by 2, where this 2 is number of row and this 2 corresponds to number of column. Let us take one more example by taking a matrix of order 3 by 3,
where it has 3 number of rows and 3 numbers of columns. Equal matrix. Two matrices A and B are said to be equal when all the ij element of A are equal to the element of B having same I and j number.
let us consider two square matrices A and B. If we compare the elements having same row number and column number of A and B, then we can see A11 is equal to B11, A12 is equal to B12.
Similarly, we can write A21 is equal to B21 and A22 equal to B22. So matrix A and B are called equal.
Let us consider two matrices A and B of order 3 by 3. That means it has 3 number of rows and 3 numbers of columns. Here the first element of matrix A is equal to that of matrix B. Similarly, all other corresponding elements are equal. So we can write Aij equal to Bij, where I is the number of row and j is the number of columns. So we can write a matrix A is equal to matrix B.
A matrix A is called diagonal matrix when its all non-diagonal elements are 0. This is an example of matrix A which has only the diagonal elements and all other non-diagonal elements are equal to 0.
If in a diagonal matrix, if all the diagonal elements are equal to 1, then the matrix is known as identity matrix. In matrix A, all the diagonal elements are 1 and all the non-diagonal elements are equal to 0. So it is an example of identity matrix.
If in a matrix, if the element of ith position is equal to that of jth position, then the matrix is called symmetric matrix. Let us take an example of matrix A. If we compare all the non-diagonal elements, we can see the element corresponding to the position A12 is equal to that of the element A21. Similarly, if we compare the element of A13, then we can see it is equal to that of A31. And again, if we compare the element A23, which is also equal to that of the element A32. Then this matrix A is called as symmetric matrix. Let's take one more example of matrix A. In this matrix, if we compare all the non-diagonal elements, here we can see A12 is equal to minus A21, A13 is equal to minus A31 and A23 is equal to minus A32, and all the diagonal elements are 0, that is Ajj is equal to 0.
Then this matrix is called as Q-symmetric matrix.